In 2023, you can't have a conversation without talking about AI or ML, ChatGPT, and now levitating rocks with LK99. But let's not forget about microservices and service meshes and all the other whole, really, nest of hornets in application development. Welcome to episode 2 of Nats FM.
Nats FM is brought to you by Synadia, the stewards of the Nats project.
So back when I started out in IT, I used to write a lot of terrible PHP applications. I tried my hand at a .NET and C++, and very much wrote applications that spoke to a database, and they had a very bad front end. So then you roll the clock forward a couple of decades or two or three, and then you wonder, well, how do I get my application to scale from simple front end to simple middleware from a simple database? And I think one of the powerful things about Nats is we have many, many insertion points to go from old school get off my lawn Dave to modern microservice kind of style architectures and service meshes and all this kind of thing. But let's not assume that you know how to get from A to B. And there's nothing wrong either with being in the camp of building things that just work and then are monetizable. So Byron, dare I ask what your old man lawn looked like and what did you build back in the day?
Yeah, for sure. I started with the LAMP stack myself, PHP, MySQL, Apache, and I moved over to the Django ecosystem, writing Python applications primarily. And I was very much also in the sort of monolithic camp as well. And, you know, it worked. It works fine. And I think for a certain scale of application and a certain scale of team, monolithic applications are the right choice for as a deployment unit, essentially. So I think since then, you know, I never had a desire to, you know, evolve to microservices. I don't think that is an end goal, but it's one of those things where when you run into organizational challenges, you know, with coordinating with team members, or you need a certain component of your application to scale differently from the rest of it, that's when you start kind of getting into this whole question of how do I carve out a component? How do I break up this work? How do I decouple things a little bit better? And that's when you start hearing the buzzword of microservices, and you get into that whole hornet's nest, as you said earlier.
Yeah, hornet's nest, wasp nest. I don't know. I don't get many hornets, I think, in our area. But I know even if I kind of go back in time and, you know, try and go to the actual memories and not the lovely, brilliant memories that I kind of curse myself with. Even when we wanted to scale applications back up in the past, it was go and buy a load balancer, take another clone of your web server. Maybe you take a read-only copy of your database for, you know, for high throughput reads and stuff. So going even from that way of thinking about how to scale applications up, and I know that these terms have been doing the rounds for literally for decades now. You know, how do we make this thing horizontally scalable, or even I think adding horizontal functionality as well. That's the other thing. It's no longer just about, you know, adding more cycles or adding more, you know, kind of response capabilities in terms of HTTP calls. So I think I'd love to cover off, even if we start with episode 2, how do we cover off load balancing? How do we go from old man monolith and talk about load balancers properly? So they're not evil. It's just times have changed, and it's easy to write now smaller components and wire them up differently to launching more components and throwing load balancers at the problem. And I think load balancers have got their perfect place in some architectures, but it'd be, can we start off with a use case maybe? Pick something simple and how we can add functionality with Nats. This is really hard to do because obviously we've got an audio version of this and a video version of this as well. And we have to describe things. Anytime we create a graphic and show it on the video, we're going to have to describe it for the podcast listeners.
Yeah. I mean, why, maybe I'll throw it back to you. Why do we even need to add a load balancer? What's the reason for that in the first place?
Well, if you think about survivability, high availability. So if I talk about things that I've got some experience in gaming, we go off to an online game, an MMO. You know, you want to spend 48 hours of your weekend playing a video game, and you go to your favorite game. It's just had a new patch, But now you've got a queue to get to the game, and what would happen is you'd have multiple inbound queues to a game. In case one of the matchmaking servers would died or whatever, you'd have a pool of matchmaking servers which the load balancer would spread and maintain those persistent connections across. And at some point the game would take over. So you think, well, there's a little bit of survivability there. There's a little bit of high availability. It's kind of spreading the load as well, not to just load up the memory and the CPU cycles of each of the matchmaking servers. I mean, this is, I think, something that we could all probably visualize at this point. So load balancer's got a reasonable place there, but in itself, it's not a horizontally. It doesn't scale, not infinitely horizontally. But it's not easy to do. This is an infrastructure problem. To coordinate an application deployment with load balancers, certainly you need infrastructure members who can take care of some of those things, and it affects a network, it affects firewall rules and everything else. Even SSL offload used to be done a lot of the time by those load balancers as well. So I think they used to do used to provide a lot of functionality. But then we moved the clock forward a little bit and well, where do we go to get some ease? Where do we go to add functionality easily without, I don't want to say committing hara-kiri, but it's not far off, without making life so difficult for ourselves that we box ourselves into a corner. I think also Shadow IT came along because of these problems. Things move way too slow, so somebody went off with a corporate credit card, signed up to AWS and made things happen on their own. I think NATS brings us a different way of attacking some of these problems.
Yeah, for sure. And since you brought up gaming, maybe that could be the use case to just riff on a bit.
Yeah.
Could try it.
Yeah, I like that. So, you never know. Might be a disaster. Might be. Entertaining nevertheless.
So when I think my experience with load balancers and proxies, and I mean, I know people conflate those things, and there's multi-purpose, software proxies these days. I know whenever I had to introduce one of these things for my monolithic app, if I wanted 2 instances and, load balance, spread the load out, it's another software component. It's another thing that you would have to manage and deploy and learn either yourself or with your team, independent of your actual application. And just as a starting point, bringing up NATS, I think one of the very interesting bits with NATS is that the whole load balancing problem is already just built in as a native primitive in the server, in the sense that you're sending a message and you can have one or more receivers that form, as we call it, a queue group, which is, you can think of it like a load balancer set of backends. And the NAT server will, distribute those messages across at random to those various members in that group, without any additional software, without any external dependency or anything. And you sort of just get that for free. So what do you say to that?
A lot of stuff to that. It got me thinking about architectures now. So I think if we go back to the matchmaking queue server, say we have 2 front end services, and let's say they're balanced by DNS records as well. So let's get rid of the idea of a front end load balancer for these things. So connection is made directly to server, and once a connection is made to the server, we can assume that they have access to a common set of resources below. Now, whether that is capacity for a gaming server, the current queue depth of admittance to a gaming server, maybe it's even an accounting system. So you think, well, we've got these kind of interesting tasks that we need to handle the second that somebody lands on our server. So what I think we need to do, again, just for the sake of visualization, if we have, again, for high availability, for survivability, for performance, we have at the top 2 services, which are your landing services, your matchmaking services, and then off to the side, a set of parallel services. So maybe, 2 for the accounting system. Somebody logs in, provides you a user ID, and then you have to go off and do some reconciliation. Have you even paid your bill this month for your game? I don't know. I don't really play a whole lot of games. Maybe your Xbox Live subscription, whatever it is. And then you might have another couple of services underneath. Microtransaction stuff, the kind of quest that you're on. And this is, I think, where even at this high level, NATS comes into its own, because then if each of the services below those matchmaking and login services are on queue groups, immediately you get nodes responding of their own accord, and NATS will take care of the load balancing between those services. So that's super powerful. And then you think, well, what about geographic? And even from a design point of view, I've seen horrendous designs where you have, like, you know, a pair of load balancers in London and a pair of load balancers on the East Coast and, you know, a pair on the West Coast. And because NATS has this queue group mechanism, it also does RTT, so round trip time responses. So even you could have one data fabric stretching between EMEA and the US, and let's call it 3 locations, East Coast, West Coast, and then let's call it London, just for the sake of, I guess, visualizing this thing. You could have the closest NAT service respond without any further logic as well. So it's not really a case of where can we use NATs. It's kind of like, well, let's dissect the problem. I think the gaming's a beautiful frame of reference, by the way. I like that. That's great. So immediately then we've got that. And you think, well, that's pretty cool. And then you get the next layer down. And before I just kind of declare that victory solved and move on, have you got anything you want to add or disagree on, or
no,
any spanners in the works?
I think it's so given that even if we have like a new game for a single player and we rein it back into the monolith, you know, and thinking about as an application developer wanting to build this game that you know is going to reach a million users at some point. The ability to have this built-in primitive, if you're using NATS out of the box, even if you're not needing to go, you know, to a certain scale and go, you know, multi-region across the globe, you're starting out with the functionality built into NATS to say, you know, if I define this subscription as a queue group that can, you know, transparently load balance messages, you might only have one member of that group right now because you don't have the load to need to, you know, deploy multiple instances. But from day one, you can design this knowing that this is a potential point of distribution and parallelism, you know, when you do need to scale up. And right, so I think that's a powerful concept that it enables that sort of natural evolution from saying I have a monolithic app, I can still use these sort of like concurrency primitives that are baked into NATS in terms of like queue group subscriptions and things like that. But I don't have to, it doesn't necessitate me to immediately say I have to deploy 1,000 of these things. You can start with one and then you can gradually scale out as the demand requires. And it'll just work because this simply means that new members will be added to that queue group as you deploy more instances, and the load will simply scale out as needed, which is pretty cool.
I think we can go back one more footstep as well here. So I went straight in at the top and went, let's keep it simple, and then proceeded to not keep it simple, and then broke it apart immediately into subservices. But if we think about a term that's been doing the rounds for maybe 12 months longer, the modular monolith.
Yes. Yep.
I think I've seen lots of groups independently using this term, including, you know, some of our own groups internally here at Synadia. This is a nice way of dividing a problem up. So we could go from, well, currently we've written this monolith and it works. You know, we've got a target user base of 1 million. Our current 10 users are doing really well. You know, the system's coping just fine. But what if we get to 20? You know, what do we do then? And it turns out the server's just terrible and we haven't got time to rewrite the whole thing because, you know, agile, ship it, move on, do the next thing.
That's right.
So if we've done this and we've gone down this approach, what if there is a really nice and clean path to go from monolith to horizontally scalable monolith? What does that path look like? So in my mind's eye, it would be divide some of the functionality within a single monolith and isolate the function calls. So in Go, you know, maybe create a Go routine or run part of the code on a separate thread that communicates. So I guess what I'm saying is internal communication for your monolith can begin to be over NATS. You can move some of that over to NATS, which means then if you can, you know, stretch your imagination a little bit, maybe to go from 20 to 50 users, what you actually do is stand up another monolith, pass in the right subscriptions or the right, you know, whatever NATS account if you built that out. And that's an interesting path.
Yep. Yeah, for sure. And yeah, I've thought about this quite a bit as well. And I think the modular monolith, there's, depending on sort of how your background and how you're approaching it. So I have appreciated in practice like domain-driven design, not dogmatically, but I think the concepts of bounded context and using those as sort of contextual boundaries, even within a monolithic, a modular monolith, is really useful. And naturally, you're going to have to identify these boundaries. You could also just have class boundaries, whatever your boundary decision point is. but you can have these boundaries, and they have to talk to one another somehow. There's a public interface, there's a public API that you use to interact across these boundaries. And that's where I think even with a monolith, you can leverage NATs as the communication, the intra-service communication mechanism, essentially, from day one. And that enables, rather than doing like direct function call, for example. And simply by using that choice, you can then know in the future, you can break it apart into separate deployable units, you can horizontally scale it, and so on and so forth. And I know, people might say, well, you're giving up the fact that there's so much performance, gained from doing in-process function calls and things like that. But it's one of those trade-off decisions of saying, well, if you can incur a tiny, tiny extra little bit of latency, but especially between the service boundaries, we're not talking about within a bounded context, you can do function calls all day, because that is inevitably going to be your unit of deployment if you've designed it properly. But across boundaries, those are potentially going to be able to be deployed separately in the limit, right? And so I think designing that intra, context communication to be able to go over NATs from day one is really powerful. And even if you start with a single process, single binary, if you happen to be using Go, you can even embed the NAT server directly into your application if you want. You don't have to even expose any TCP connection there. Or you can have an external NAT server as a starting point, and it's simply brokering all of the communication between your components.
And I'm just going to pin you right there because my brain's about to explode. So if we think about then the path from get off my lawn, old man Dave writing his crappy PHP back in the day and .NET and everything else, and then we kind of go, hey, well, it's not that it's bad, it's just that a lot of companies still maintain this kind of modular approach because it suits them. But you get to a point where you can have some really weird offsets in terms of performance. So part of your code has got a lot of hot paths and a lot of it might suffer. So some of your cooler paths might suffer because of the hot paths. And I think this is where this kind of like modular monolith approach comes in. So you could have part of your hot path code and an instance that's less busier maybe, could serve a response to something less critical. And also provide that kind of, I guess, resiliency still. You've not lost anything. In fact, you're gaining some performance in really weird, say really weird. No, I think it's just, again, you end up with a lot of hot paths in some monolith code, where you can have a not so busy instance, provide some functionality without asking too much from the resources. And also it's a good way of identifying early candidates of what can be extracted and removed as well. So this, my brain's beginning to implode at this point. And then by embedding NATs, we gain some superpowers, because once NATs is embedded into your modular monolith, connecting that instance to another modular monolith, you build a cluster out effectively in slow-mo, which is kind of cool. Yeah.
So there's definitely a natural evolution there, and you can identify those hot paths, like you said, those are candidates, and you will naturally then, break that bit out, and you can deploy that. There might even be their own life cycles of development. There might be some really solid components that is like, this is an integration component, I'm probably not going to change it that often, let's say. But then there might be business logic that you're actively changing all the time as your business evolves or the game evolves or what have you. And those might need to be more rapidly deployed, and it would be nice to sort of separate out that unit to be able to, change over time more quickly, and their cadence is going to be different. And then as your organization grows, this was one of the drives for, microservice adoption in the first place. It's just like, it allows your organization to scale. That was one of the promises, but it's like, not everybody has a giant organization, but you can still reap benefits when you do need to scale things independently or you want to deploy independently. And starting with NATs as the communication mechanism of your components from day one makes that transition very natural. Whereas if you start with intra, function calls and object method calls and stuff like that, then you're like, okay, how do I transition to a distributed system? How do I transition to microservices? And then that's when you start saying, oh, maybe I need to use a message queue like RabbitMQ, or I need to do streaming. So let's do Kafka. You start bringing in all these things And it's like more technologies to learn, more dependencies to bring in, more operational overhead, all that stuff. And then it's like, well, if you just started with Nats from day one, it'll serve all your application needs. You can do streaming and KV and all that kind of stuff, but it's sort of a nice starting point. It's almost like more like a framework to base your messaging and your connectivity needs on top of from day one. So
again, my brain is spinning here. So you mentioned a really interesting point earlier on where I think we're borderline. You kind of lightly touched on the polyglot nature of things. So if we have, for instance, let's have a think. So we go back to the gaming stuff. We've already covered, say, login and matchmaking. So you've logged in, your account's good, you get shoved onto a game. Right, great, you're in. You crack your beer open or whatever it is that you do, and then some little punk comes along and kicks your backside into the next eternity, and you're like, what the? My feeble sort of whatever's just crap. So I'm going to go and buy a new one. So then we start talking about microtransactions. And they're a thing. I wish I could share some numbers, actually. I was involved in some of this stuff like a long time ago. But microtransactions are pretty much what drives monetary gain for a lot of these organizations now, beyond the initial game deployment and the licensing and everything else. But there are always different teams. The core engine and the gameplay team, and they're different to the monetization, and invariably with very, very different skills. You might have a team who'll build a dashboard, they'll integrate with payment providers and do all anti-fraud and stuff. In my experience, the kind of core game developers do not give a damn about that stuff. They don't want it. They want to give you some hooks for those developers to work together. But what it looks like in the past is you'll have, especially for console games, like C++ code for the actual game itself, and then they come along and go, yeah, you can write your microtransaction stuff in C++, and all the .NET developers are like, no, we're not doing this. So you end up with this horrendous kind of mishmash going on, where either terrible C++ code or overly optimized .NET, because it's what happens when core game dev meets transactional developer.
Yeah.
So Nats plays into a beautiful thing here as well, I think, because if you can come up with whether it's protobuf, JSON schema, or something, and you can agree what payloads look like, then each team gets to use their beloved language without making any, what's the right phrase I'm looking for here? Religious sacrifices, or going to war with each other.
Yeah.
So you get some division, some polyglot division.
Yeah, that's another great point. Yeah, you have your majestic monolith, or whatever you want to call it, and some things do need to be optimized more. I mean, I think when Go was on the rise, the same story has been with Rust and Zig, any of these newer languages. They're always like, oh, there could be this one component in my architecture that I'd really like to optimize the heck out of, or I need a certain degree of safety in terms of the language and the runtime that it provides. And then they just want to carve out that piece. And again, you inherently can't do function or method invocations at that point. You have to split it out into a separate components and now use the network to talk. And again, with the polyglot nature of Nats and all of the supported client languages and whatnot, that's again supported out of the box, really natural. So it allows that kind of evolution, that dimension of evolution as well for your application.
But there's another benefit, a massive benefit here as well. And God, I wish I could There's
too much to talk about.
There's way too much to talk about. And I think episode 3 and 4 are probably going to be on more evolving this, more microservices, service meshes, that kind of thing. But one of the workflows that was always interesting was when player bought magic slaying sword of Bob, I don't know, whatever. And then they hand over to the transactional code. Payment go through, weapon is given, is added to the user's inventory. But then the thing is, what is it? It's a database dip. It's an unreliable message on a message queue. And I think this is the other thing. It's like my brain immediately goes to, how would I do this with Nats? So I'd do it in a KV. I'd have a player KV inventory. I'd be watching the KV inventory from the game with the C++ client, and then my transactional code would update that bucket and the key in the bucket. The game would immediately get the notification that the item's been added, and no database dips required.
Yep. Yeah. Yeah, it's a superpower when you start thinking about, I mean, again, I started the journey, old man Byron started the journey with, databases, and it's like that's the only way you can store state. That's the only way that you can query anything or do anything useful with state. And it's like over time you realize that, there's different kinds of state management, there's different kinds of patterns that you need. And I think streaming and KV, there's other storage systems that are very, very useful and highly optimized for certain use cases. And I've come to appreciate that when I talk about a database, I'm more so talking about relational databases using SQL. I know there's obviously other forms of databases as well. We went through that whole NoSQL movement, which was a bunch of hilarity, but
hey, I love those. Didn't you pick up my beloved NoSQL databases?
It was good for the industry. But yeah, so SQL or any of these, query languages, they are just that. They are query languages. They are interfaces for you to do something with the database or with that state. So sometimes key value, sometimes watchers, sometimes streaming, that is sufficient. That's a sufficient interface to get things done and can be quite optimized compared to you needing to say, I'm going to ask my database like often all the time for an update. And it's like, well, if you invert that and you can just stream it out and you can model your state transitions in that way, then that can be very powerful and way more responsive, of course. So
yeah, hugely responsive. And depending on how you dimension those systems, you could put some things in memory, some things on disk.
Yep.
And you end up with the things that you need most, much like you do normalization and forms around a database. You could manage your data in the same way using NATS. So things like user inventory, when they log in, you might need to put it from disk once. But this is where that horizontal scalability thing comes in. You'd end up putting the inventory into a bucket on a machine that's got capacity on memory, and then it's in RAM, and it's blisteringly fast. And let's face it, you don't find many console-style game backends running, on a $24.99 a month VPS of virtual machine. So networking hopefully should be there to allow some, fast communication. But yeah, it's absolutely fascinating. But we are coming up on, I think, grokkable time for this episode. Have you got any takeaways that you want to leave our listeners with? Assuming we've got any at this point, by the way. Who knows?
No, I think this was sort of hopefully a useful discussion and sort of perspective foundation for where NATS fits in, and that it's not, even though NATS is a incredible enabler for microservices and massive distributed systems, global distributed systems, if you don't have that problem, NATS can still be very, very useful to you as a starting point, even if you do need to eventually break up a component or your application into components over time. But it's super lightweight. It's very fast inter-service communication, intercomponent, intercontext, whatever your module is. And it just opens up all of these doors for being able to be polyglot, scale out when you need to, break off a piece because it has to, scale independently. So that's my initial takeaway. But I think before I ask your takeaway, I think I'm just looking forward to the next couple episodes at least to talk about. We touched on microservices from the standpoint of like a team and organization, and how NATS multi-tenancy features and all of these things actually play and allow you to evolve your organization and your application together. And there's a lot of really powerful features in NATS to enable that. And then, getting into, all right, now maybe we've gone the microservices route or more generically distributed systems route. What are all the really fun, fancy things that we can do, and how can we extend it out bigger and bigger outside of maybe your traditional, LAMP stack app or Django app or Rails or something.
Yeah. And before we get lynched publicly, Yeah, I by no means, declare that any of that's dead. It's horses for courses. So before anybody starts sending some comments saying, "Hey, that's how I do 2 million a year on our business on that," good for you. And we're not saying it's terrible, but sometimes you need to break things apart and do things differently. And it's not because you have to. It's just sometimes it's worth doing. Actually, my takeaway is I want to go and check out PHP again.
I've heard good things. The recent versions. I've not played with it either since I don't even remember the version. 4 point something. I don't know.
I daren't even start coming out with version numbers. In fact, I think I've got it started off as a white book and now it's very much beige and coffee stained in the cupboard somewhere behind me. So I'll dig that out maybe for the next one. I think episode 3, episode 4, if you're interested in this, we'll probably be taking a bit of a deep dive into actual microservices, service meshes, and maybe some hot contentious takes as well on that, just because there are a few to talk about.
Oh yeah,
massive complexities I think that we can reduce, and I think we've all seen those social media feeds as well. It was like hashtag we went down the microservices and regretted it, and we've gone back. And I think we could talk about that and why that happens and how to prevent maybe that kind of sprawl and losing control, which would be interesting.
Absolutely.
Yeah. Okay. So thank you very much for listening or watching. Again, we do both audio and video for these, and hopefully our terrible descriptions have been good enough as we've been looking at some use cases and some mental projections. I'm probably going to do this as well, and this makes me kind of cringe, but if you've enjoyed watching this, give us a like, give us a thumbs up, give us a comment. It gives us a little bit more mental energy and a little bit of juice to do the next one. So thanks again for listening. We'll catch you next time.